Okay, most important, make sure you've done this activity before you start watching this video. This was posted in the Mayhem folder. I've given you a data set of diameter and circumference, and I tell you which is which for the x and the y. Diameter is x, circumference is y, and you're supposed to have your graph here and have taken the time to figure out the equation of your line of best fit. You would have had a scatter plot, you would have drawn a line, and then figured out the equation of that line. So make sure you do that first. After we do this video, you should be able to do all of that homework. And remember, on the ones that I don't list exactly what to do, there is the homework set listed in the syllabus module, so that's always what I'm referring to. This one I'm just giving you a hint for 2A. That sea level means 0 feet, and I'm giving you a hint for 2F. And then from the real life algebra handout, do number 1, 4, and 11 before you watch the next video. So let me kind of talk about this data for a minute. So when we're in the classroom, this is one that I actually put y'all into groups. I bring in a lot of circular objects and measuring tools, measuring tapes, those really soft measuring tapes that people who sew use. They're very handy. You can usually buy them for $1 or $2. We bring in rope or yarn, twine, because sometimes that's very handy to be able to wrap twine around a coffee can to be able to see how the circumference and then measure it to a ruler. So really, I'm disappointed that we don't get to do this activity, because just trying to teach kids and for us to practice how to measure something accurately is an activity in and of itself. Also, how to read measuring tapes and convert 1/8 or 5/16 into a decimal. So there's a lot going on there that we had to skip. So again, this was data from last summer. Now, this is an activity that we can hit at in so many different ways. We, of course, part of this video is going to be hitting at equation of linear lines. But before we do that, I sort of wanted to back it up. Maybe back it up to 4th or 5th grade. So I'm just going to hold this up just to point out, let's say you're not doing equations of linear lines. Well, you could you could have the students do it with a calculator. What I'm showing you here is on Excel. This was the data set, right? And then I divided circumference divided by diameter for each of the particular objects that we measured, and then I took the average. So hopefully everybody has figured out by now that we're trying to discover pi. If you Google discover pi activities, this usually comes up. Now pi is 3.14, etc. So you can tell how some groups actually were overestimating, some were underestimating, but on average 3.3, that's not bad. We only had, 7 data points? If you had 20 items that you measured, you would probably definitely come up with an average of like 3.1 or 3.15. So you could just come at this proportionally, right? That it always seems like there's about, well, according to our real data, a little over 3 diameters in a circumference. Again, we actually know the correct answer is 3.14, but of course there is measurement error when you're trying to measure this stuff by hand. So that's an activity just right there that can reach 4th, 5th, 6th graders. Eric Brescia, I think he actually teaches now in the College of Education. He used to be a 3rd grade classroom teacher, and he actually said in his 3rd grade he had, those circular weights, free weights that you can load onto, the barbells. He would bring one of those in, and he would lay out a long piece of butcher paper, and he would paint around the edge of the circular weight, and he would then roll it out on the butcher paper. So the third graders actually had a visual of their circumference of that circular plate, right? Then he would lay down the plate and go sort of like flip it head over tail to see how many diameters filled up the line of paint, which was their circumference. For the third graders, he was simply just trying to get them to see, oh yeah, there always seems to be about 3 widths or diameters of this circular object in their circumference all the way around. So trying to show you that this activity definitely works from third grade up through, actually I want to say math 307, because in math 207 we don't do as much with this activity as we could. I'm going to cut to the chase here. In 307 there is a formal topic. It's called linear regression. You're looking at your one graph, right? But you can imagine I have 44 students or whatever, so there are 44 of these different graphs where you guys eyeballed what you thought was the line of best fit. Well, there is theoretical statistics steeped in calculus that actually has figured out what the one line of best fit is, and it's been programmed into our calculators, into computers, etc. We're not going to talk much more about that, because again, that is a 307 topic. But I did at least want to show you, I ran it on Excel so I could print this out and show you. Here was your data. This line that is drawn here is the theoretical one line of best fit. And here is the equation. So, of course, again, there was still measurement error. It was very hard to measure those objects in the classroom last summer. But you can see that the slope they came up with was 3.12. Pretty darn close to pi, right? But this is the computer using the formulas that have been programmed to actually show you what the best line of best fit, not just up to our opinions as humans, but from theoretical statistics. So this is sort of AP Stats topic, Math 220, Math 307 topic, but I just wanted to show you what perfection looks like. So we've gone from third grade up through Math 307. Now, what I do absolutely want to come back to, because we're not in the classroom, and I can't walk around to see possibly who struggled with this and that type of thing. So have your picture out. Part of the documents that I loaded for this video is actually my own personal picture. You don't have to write this right now, but you would have had your graph, right? Probably looked much better than that. You would have drawn your line. Then I told you to pick 2 points on your personal line. You would have calculated the slope, and then you would have used one of 2 things to get the equation. I want to briefly talk about the slope. The slope that you should have gotten, I know there's 45 of you, needs to be somewhere approximately 3. I'm just trying to give you an idea if you did this problem correctly. Usually in the classroom, students probably come up with somewhere between 2.5 and 3.5, which is all perfectly fine. Make sure you did not come up with a slope of like 0.3 or 0.5 or something. That means you calculated slope wrong, incorrectly. Because remember, in case you're like, uh-oh, I did mine wrong, y2 minus y1 over x2 minus x1. Make sure you haven't flipped them. Okay, So, in case you were struggling with how to do this, again, I can't help you with your exact one, so you may want to take a look at mine. I graphed my points as best as I could, and then I drew a line with my red pen. I used my ruler, looked pretty good to me. Then I tried to pick maybe the intersections of the grid points because I felt like that would make being able to identify what 2 points on that line were. So that's why I just circled them. And then I personally wrote my 2 points right here. So again, if you struggled with this activity, redo by looking at mine to make sure you understand it. So one helpful hint, because again, I tutor a lot of students in algebra. You know how most books and a lot of workbooks, they'll give you the 2 points next to each other. I find that then it becomes almost a visual exercise. Students get very confused. I really always like to write my 2 points, what I call vertical, one on top of each other. I mean, there's no way around. Our students and you and me have to remember to do the difference in the y's first. That's the numerator. Difference in the x's is, of course, the denominator. But when you put your 2 points on top of each other, you can just kind of read downwards. 6 minus 17, and then 1.75 minus 5.25. I got a slope of 3.1428. I seem to do incredible. I think I just got lucky. Let me make another comment on this on the whiteboard for a second. You do not have to write this, but I want to make sure everybody understands what I'm trying to give as a helpful hint if you ever have to teach this. Most of the time, textbooks will say, hey, here are 2 points, calculate the slope. So students sometimes having to move back and forth here to here and here to here, they end up getting it all confused. When it's underneath each other, it's much easier because things line up, as opposed to having to move back and forth in a horizontal way. All right, so let's keep going with mine, just in case you struggle. So my 2 points were this. Okay, so I said my slope, difference in the y's. Now, if I start top minus bottom, of course, I have to keep going top minus bottom, right? I have to be consistent. That turned out to be 3.1428, okay? So I have my slope, and I have my points, right? This is a point. I know I have 2 points. When we do this in the classroom, I would say most of you then use the y equals mx plus b form. So I'm going to show that to you, but then I'm going to encourage you to practice the other way also. And then particularly if you're ever teaching algebra, even though you might have a personal preference of how you solve something, you always need to show the kids all of the different ways. So using what I have here, most of you prefer this. You're going to put your y in, you're going to put your slope in, you're going to put your x in, and then you're going to solve, well, then plus b, right? And then, oh, I picked up my phone, hold on. Then you're going to solve for b. I haven't done it this way, so let me go ahead and figure this out. Yes, 0.5. And then you have to rewrite it. Y equals mx plus b. So that's the equation of the line in mx plus b form. So that's that technique. Okay? It's a fine technique. There's nothing wrong with it. You solve for the intercept, then you got to plug the stuff in using mx plus b. I just want to make sure that you're okay with the other way. The way I did it, I used point slope form. y minus y1 equals slope x minus x1. So my y and my x are going to stay as y and x. The point I'm plugging in is the x1, y1. So minus my 6 equals slope x minus 1.75. So now you just have to work it out, distribute parentheses. And then add your 6 to both sides. And of course, you are going to get exactly what we got this way, right? So just two different ways to work with a point and the slope that we had calculated from our 2 points. So make sure you understand there's quite a few homework problems that just randomly give you 2 coordinate points and say calculate the equation of the linear line. So you can do either procedure. Again, it's always funny rambling on a video when I can't look you in the face. Another great example that I often do during the semester if there's time, and we probably would have had time. It's called the Vitruvian Man. So I just want to make a few comments. I'm just trying to give you ideas of things that you can do in the classroom and ideas that actually hold. This one holds from probably kindergarten through college. This is actually an NCTM approved activity. I'm all about cross-curricular. This has history and art history and biology and mathematics and statistics. It has everything in it. I may have a reference packet somewhere on Canvas, but don't quote me now, but like in 60 BC, something like that, Vitruvian actually measured the proportions of human bodies. Of course, it would have been male human bodies at the time. Then, later, Leonardo da Vinci actually drew it. If you've ever seen Vitruvian Man, he tends to have his arms straight out. A lot of times doctors use it as clip art. I'm sure you're familiar with it. He measured lots of different proportions of the human body. The one that I think is completely appropriate and easiest to do with a group of kids of any age is to get the height in inches. That's an activity in and of itself, to have students work in groups and line up against a wall and use some type of book that is perpendicular to the wall to get the exact height. Arm span, tip to tip. We always go across the back, never across the chest. And then foot length without the shoe on. We don't care how long your shoe is. We want to see how long your foot is. So just like I had mentioned with circumference and diameter, you could go, 4th, 5th, 6th grade by just looking at the proportions. How many foot lengths go into height? Usually it's 6 to 7. For girls, it's more 6. For guys, I think it's more 7. If you do arm span and height, you will realize that those are about the same. The proportion is 1, particularly if you average it over, say, 20 students or something. One thing that I wanted to mention that someone has done in kindergarten. Kindergartners, you lay out those big paper and you can have the child lay down and have their partner just trace their body. And I know a lot of times you'll hang them in the hallway and let the kids decorate them or whatever. Well, leave it on the floor. So you actually have where they traced their body from head to toe, right? Then have them take their shoes off and do a little heel to toe of how many of their feet actually fit onto their height. So that's a way to do proportions and measurements even in kindergarten. So this is when I teach 307, we do a lot of this. We do it at all different levels. This will work for algebra class, just like we did with circumference diameter. You could just graph those two, or you could graph those two. Those are probably the best two. So just a lot of different ways to practice measuring, practice linear lines, practice proportions. I know I have used that word proportion a lot, and I know your book talks about this too. I may have already put this on a video, but it bears repeating. Technically, proportional is, okay, the y-intercept is 0. It is a strict proportion, right? Because there's that fraction, there's that proportion. And of course, that's what we mean by the slope. Now, circumference diameter, not the way we did it, because we measured our own data, which kind of messed things up a little bit because we cannot measure perfectly. But let's go back to the geometric formula for circumference. Oops. It's 2 pi r, right? Well, this could be a discussion in and of itself in algebra class or pre-algebra class, making sure that students know you can rearrange the order of multiplication. So I could write this as 2r pi, and then 2 times the radius is actually d pi. Pi is a number. You know how normally we don't write x5, we write 5x instead? There's no reason to have the pi on that side. It would probably look much better if we put the pi in front of the d. And this is exactly what we did if we had been perfect, taken perfect measurements last summer. That would have been the formula, and that is why I had you put the circumference on the y-axis and the diameter on the x-axis. Geometrically, this is a proportional relationship. Of course, we did not come up with that perfectly in our real-life example, just simply due to measurement error. Some of you like to get organized. This is actually talked about in chapter 13.3. All right, looking through my notes, this video is sort of a hodgepodge of just trying to pull a few things together. Now, we're on the topic of linear lines, and I particularly wanted to start with circumference diameter because, yes, it probably makes sense. Oh, if you have bigger diameter, you have bigger circumference. And what does that 3.14 mean? Yes, it's the slope. We normally get our students really good at calculating slope from 2 lines, right? Just mathematically crunching. But I think the one thing that we need to practice more of is interpreting the slope. So this is getting into chapter 13.2, and we are actually going to come back and do it for our circumference problem. Well, let's make sure everybody's okay with, if you have positive slope, one of 2 things happened, right? You either had a positive number over a positive number, or you had a negative number over a negative number. They both make positive slope. So if you have positive slope, when we're actually making sentences with the actual variable names, you can make both variables go up, or you can make both variables go down. You always have 2 choices. Now think about negative slope. How do we get a negative number? Well, maybe your numerator is negative, or maybe your denominator is negative. All that means is one of the variables is going up while the other goes down. It does not matter which one you make go up as long as you make the other one go down. All right, now let's remember what our slope formula even is. I'm trying to set this up for when I give you a interpretive sentence, it's going to make sense. All right, change in y over change in x. But what happens if we just change x 1 unit? You know, maybe x goes from 4 to 5 or from 10 to 9 or something. Well, the change in x would just be 1. And I don't have to show the 1 in a denominator of a fraction, right? So really, the change in y would then equal the slope. Okay, who cares about all that? Well, that helps us make an interpretive sentence. If you memorize it, then all you have to do is apply it to the problem. Hopefully it makes sense based off of how do we even calculate slope. So, but I put quotes around it. I can't tell you if you're increasing or decreasing yet because I don't know if your slope is positive or negative, right? So you're not going to write both of those. You're going to have to decide. The units of the problem are very important, and this 1 is very important because if it's a different number, then this is not a true statement. Okay, let's apply this to our circumference problem. Then I have another problem we're going to apply it to. I'm going to erase. So that is about what I got earlier, right? Even though I know it should just be 3.14x, that's actually what I calculated from my personal line that I drew on my personal graph. You could use whatever number you had from your graph if you did it properly. All right. As x, the variable x was diameter. As diameter, now this is a positive slope. You can make them both go up or both go down. It's probably, most people tend to make them both go up. As diameter increases 1, I don't think I ever told you, but that data I gave you was in inches. Sorry, I forgot to tell you that. As diameter increases 1 inch, circumference increases 3.14 inches. Okay, we know this anyway. But just applying it to the problem, I put in all the pieces. This is what I call the foundational sentence. I used the 1 and I used the slope because that just comes from my slope formula. At this point, because it's proportional, that's what slope is, you are welcome to tweak it. What happens to circumference if I increase diameter 3 inches? I'm trying to keep to what's on my notes. I was going to change it, but what happens to circumference if I increase diameter 3 inches? Well, increasing diameter 1 inch is circumference 3.14. We're just dealing with proportions, right? So if you want me to increase diameter 3 inches, you multiply that by 3, then I better multiply that by 3. Circumference will increase 3.14 times 3, which is 9.42 inches. Okay. All right. Let's do slightly more confusing problem. The book on some of the homework problems I have assigned actually ask you to interpret the slope, and this is how I want you to interpret it, with the variable names and words and sentences, just like we're doing here. In Math 307, I have an activity where I make them go to eBay and look at cars that have sold, and I have them look at the mileage and then the price that the car sold at. So we're cutting to the chase here. Okay, the mileage on the car on the odometer was X and the price of the cars was Y. And this was one student's formula. Okay, just like we did the activity circumference diameter, they had to do the activity just with price and mileage. So we want to do an interpretive sentence. As, okay, X is mileage. Now hold on, my slope is negative, so you can make whichever variable go up as long as you make the other one go down. It does not matter. There are two ways you can make this sentence. So how I'm going to make it go up. As mileage increases 1 mile, price is going to decrease 0.0618. This was American dollars on eBay, right? So I'm just going to put the dollar sign. Make sure you know how much money that is. That's about 6 cents, right? And it's the correct statement. But a couple things here. If you've ever gone to shop for a used car or anything like that, I don't really know that anyone cares if one car has 1 more mile on the odometer than another car, right? I'm not convinced anybody cares about 10 miles or even 100 miles. I had to shop for a used car a month ago after someone crashed into my daughter. I was comparing cars. I did not care if one car had just like 100 more miles than another car that I was looking at. So let's make this a little real life. So right now, we have mileage. If it goes up 1 mile, then the price, well, we know one's increasing, decreasing. I'm just going to try to cut that part out so it doesn't look too messy. If the mileage goes up 1 mile, the price goes down 6 cents. All right, well, let's up that a little bit. What about if the mileage goes up 100 miles? Okay, you have to times 6 cents by 100. That would be approximately $6, right? I still don't know that anybody cares about that. Honestly, when I'm shopping for cars, I care in increments of 10,000 miles because I'm talking used cars here, right? Not a new car. So at 100 miles, it would be $6. What about at 10,000 miles? All I did, 2 more zeros, right? I had 2 zeros. I just put 2 more zeros in there. Approximately $600. If you're looking along with my notes, I think I had kept that at 2, so that's where you're going to see $6.20 and $620. That's not important. The most important thing is that you know how to multiply and that you also have an awareness of, in real life, nobody's going to care about 1 mile and a nickel, basically, right? That this is much more useful information. I'm looking to see if I've forgotten to tell you anything. I already put your homework up. So after the homework I put up earlier, all the book problems. At this point, I've assigned all of the book homework for the stats portion. So if you're keeping track of the ones that you've done, make sure you've done it all. Real life algebra, I've been kind of just assigning a few at a time. But again, please try those real life algebra problems before you watch the next video. I will be going over them. The answer key is posted also. So use my answer key. Work with it on your own first. Then when you watch the video, when I'm actually doing them and you can listen to me explain them, it will just really reinforce what's happening if you've spent time on it beforehand. All right, we will see you soon.